An introduction to the ThingPilot IoT ecosystem. The primary goal of ThingPilot is to allow anyone to quickly and easily create IoT products and IoT-based businesses. At the heart of the ThingPilot ecosystem is the ThingPilot Cloud Platform, which is designed to make it easy to collect data from internet-connected things and generate useful insights based on that data. ThingPilot splits things into two distinct categories: assets and devices. Assets are the things a user might want to monitor, for example, a car, a person, a house, or anything that can be imagined. Devices are the internet-connected elements that monitor assets and send information about them to the ThingPilot platform. In the ThingPilot platform, assets can be defined in a hierarchical manner. For example, a top-level asset might be a car, which can contain child assets like wheels and an engine, which itself can have further child assets like fuel injector, carburetor, and so on. All ThingPilot compatible devices measure what we call metrics, which are some physical quantity sampled over time. Common examples might include temperature, pressure, or battery level, but any conceivable metric can be transmitted by a device. The ThingPilot platform allows users to create their own asset type and device type definitions to suit their needs for a particular project. An asset type is a generic description or template that describes a class of assets and from which individual asset instances are easily and quickly derived. For example, a user may define a car asset type and from that template create several car asset instances with their own unique identifiers. When defining an asset type, a user can currently set the name of the asset type, a flag to determine whether individual assets have their own name field, and the type of unique identifier used to differentiate between asset instances, such as incrementing ID or UUID. Similarly, a user can define device types, which are templates for individual device instances. When defining a device type, the user sets the name of the device type, the type of unique ID, such as UUID or MAC address, the application layer protocol used by the device to upload metrics such as HTTPS, COAP or MQTT, the type of authentication the device is used to access the platform, such as API keys or mutual TLS, and a definition of the metrics groups that this device is able to measure and upload. A device type definition can also optionally contain a set of upload groups, which we will get into later. A metric group is a set of metrics that are sampled at the same time and thus will always have the same timestamps. For example, a device type might define two metrics groups, one called environmental and another named system. The environmental group might contain two metrics, temperature and humidity. This indicates that these two values are strongly tied together and are always measured together. In our example, the system group has just one metric, battery level. Because this metric is in another metric group, the device may measure and upload this data separately from the environmental data. Once a set of individual device and asset instances have been created, a user can create a mapping between the device's metric groups and one or more asset instances. This means there can be a many-to-many relationship between devices and assets, making the ThingPilot platform highly flexible. For example, one particular device may measure metrics about two different assets, or indeed, two separate devices may measure different metrics for a single asset. If a metric group for a particular device is not mapped to an asset, the metrics are instead associated with the device itself. This is useful for recording self-diagnostic information such as battery level. Beyond simply recording metrics, ThingPilot Cloud also provides a large library of insight functions. Insight functions take one or more metrics and produce some sort of insight. Insight types might include simple functions such as averaging or scaling, time series analysis tools such as trend fitting, interpolation to other time series or Fourier analysis. User configurable supervised learning functions will also be available, which can generate models based on user labeled metrics and produce classifications, predictions and anomaly detections. A special kind of alert will also be available, which will allow the user to trigger emails or send data to third-party APIs under certain conditions. Insights will be set up using user-defined insight chains, which will define the data sources and a series of insight steps to produce the final insight that the user is interested in. Outside of the cloud platform, we're also developing a range of hardware products called Node Cores, which will enable an IoT developer to rapidly produce a new IoT product and then scale that product for mass manufacture. A ThingPilot Node Core is a module containing antenna, comms module, microcontroller, non-volatile memory, an encryption module and solderable input-output connectors. These form the core of most modern internet-connected devices. By using a ThingPilot Node Core as the basis of a new product, a developer is able to focus on what makes their product unique. The different varieties have the same form factor and are designed to be pin compatible, meaning that a designer can switch from one connectivity technology to another without redesigning their entire product. At the moment we have prototypes for NB-IoT and LoRaWAN compatible node cores, but we plan to add more options in the future. We also provide a software SDK for the Node Core modules called NodeFlow that makes it even easier for a developer to get their device connected to ThingPilot. NodeFlow can be configured using a set of metric groups and upload groups. Metric groups are comparable to the metric groups defined for device types in the ThingPilot cloud and additionally have a measure trigger property. This defines when a particular metric group will be measured, either on an external interrupt, for example a button press, on a schedule, for example 10 AM, 5 PM Monday to Friday and 11 AM on a Saturday, or on a timer, such as every hour. Similarly, upload groups define which metric groups will be uploaded together and by what kind of trigger. This allows a device to, for example, measure one metric group on a 1 hour timer and a different metric group on a button press, store that information in the device's non-volatile memory while the device sleeps between readings, and then upload both metric groups to the cloud every day at 10 AM. That's a brief introduction to the ThingPilot ecosystem. Thanks for watching. To learn more about ThingPilot, please visit thingpilot.com.